twice a week. We take the ovaries and we put it on this trans illuminator. So can you shut the light down? Yeah. So any liquid that we have, we can see. So when we put the ovaries on it, we can see the follicle, because the follicle have a follicular fluid. And what we have in the follicle? Inside the follicle? The oocyte, right. So we want the oocyte, okay? So we are using, you can light on the, put on the light. So we are using a syringe and this needle, and we're aspirating from the ovaries about 10 oocytes we get from each ovary. So usually we get 20 ovaries and we have 200 oocytes. So we have 5 groups of 50 for each replicate. So, and we are doing it 5 to 8 times. So in order to finish this kind of study, we have 1,500 oocytes. So it's a big population of oocytes. Why? Because we don't know the source of the mother, which farm, which nutrition, the season we know, but we don't know nothing about this cow. So in this case, if you are using a lot of oocyte, you reduce the differences or deviation between cows. Okay, so we have finally we have a bucket of oocyte, and we are using this pass-through window to pass the oocyte to this room. This pass-through window is very simple idea. You cannot open the other door unless you close this one. Here the contact, and you cannot open. So in this case, we cannot pass any environment from this dirty room inside to the IVF clean room. Okay, because in this area we don't have the FFU filter, HEPA filter, and here also we are working with this coat, because working with the seminal fluid, or sorry, follicular fluid, is like plasma, and it's you can get dirty. So in the day that people working, they are coming with, you know, working clothes, but we're using this one. But for me, it's more important for the people that when you are working dirty, you are using this one. And now when you are going inside to work clean, you have to change the code. So it's like psychological doing in order to make switch with your in your thought, in your way of thinking. It's okay. So while getting room, people use it for dressing room. We have HEPA filter here. The room is cleaner. We get positive pressure from the other room. What we are doing here, we are using these Crocs, these shoes, because only guests using this cover. So people that have to work here, getting into this room, they are going to spend here 3 to 4 hours. So it's better everyone has his shoes. Recently, my technician bought me a new one. Look, a new one for the new year. So and we have also white coat with short sleeve, because it's very hot inside. So it's not really clean room inside. We're not covering the head, but we're doing the basic doing for keep it clean. So the most of the contamination is by shoes. People going outside can step on dog shit and coming here, and it's happened to everyone, right? And I think the most of the clothes of the people is clean, so we put a coat, and we don't have hair, so we don't have to cover the hair. No, but
no, but for ladies, they might.
I don't afraid of this contamination. I want the people also to feel comfortable, and to work in a good environment. This is the reason that also we're using a short sleeve, because I want them to work. What we're doing, we are using alcohol for the hands, 70% alcohol. So this part of the room first you can see the microscope, that most of the picture that Alisa showed you outside is taking from this microscope. The microscope is motorized, inverted. You know what is inverted? That the objective are coming from down and not from after. We have a very strong camera. It's a fluorescent camera. And it motorized, so we're handling all the microscope by this unit. So you can see people spending here a few hours in order to analyze their...
Most of the time you only use the screen or you look inside?
We are looking inside, taking the shoot, and they're analyzing on the screen. Because you can take it and go to sit in your bench. Now, we work in this system 2 years. And we published, Alisa published 2 papers. But we get to the understanding that you need the other machine, the flow cytometer. So we just last week set up this machine. And now we are going to compare the result from manually counting and the machine, and thereafter we move to this one because we just know how it works and how it's. So we now have to adjust the old system to the new one. It costs a lot of money, this machine, but we got it as a donation from the insemination center because they want to make sperm quality to the semen. So we took advantage of it and we bought the machine. As you see, they have a 96 plate to use there. We don't need such a lot. We can use few vials, but this was bought for them. And now we can use also this machine for our needs. Some other scientific lab can do everything manually. There is a software that tells you to count. So it's a lower system, but it's still good for science. So you put a master student and you can work and do the work, and it's very nice. But if you want to work with a big amount of sperm, you need a machine. Here we go to the second part of Alisa PhD, and she has a lot of work to do, so she's going to use this machine. Here we have the semen tank, and here we have the reserve computer.
How many degrees?
It's liquid nitrogen minus 96.
96. Always stays like this, 96. And this is also the storage, so if it stays 96, no problem.
Yeah,
the storage for
we check the level of the liquid nitrogen once a week, and we keep it full, and that's it. The procedure of freezing is more sophisticated, but when you get to this stage, it's a slow freeze. Yeah.
And the same if it's taken out again, slow.
It's faster. With the embryo, you have to be careful because during the thawing you can damage the embryo as well. So here we have this is a sperm second set of incubator, because we bought a new incubator inside, so we took it outside, but we must keep it in order to have a backup for our study. Okay, so let's get in. Clean room, it's IVF room, it's well equipped. So let's go from this side. We take the whole side and we go to the bench in order to pick up the good quality oocyte according to their morphology. We don't do any invasive. You can see that the microscope are inserted in the bench, and this part of the bench is warm. This is cold and this is warm, but we have to put on the circulation. Warm water with circulation. There is a bath. This is a bath. So we get within half an hour a warm bench. The idea is that when you put the plate with the oocyte or embryo, you keep the right temperature, right? And you don't cause a cold shock. Another thing that we've done recently, we inserted this small incubator into the laminar flue in order to eliminate to opening the incubator. So everyone that is working is taking the stuff from the incubator, going here once, putting here and doing all the procedure, and thereafter putting it back, because this incubator is not for 1 people, it's for 5 people. So if you all the time open the incubator, you can damage 5 experiments. So, and we have a problem with it, so I decided to do this system. And I got it because this incubator has a record of the opening. So once I found we have a problem, so I figure out that every 10 minutes people open the incubator, and it's impossible. So another system that we have here, that we have 1 incubator, but we have 4 doors. So each one is student using his own door. It's not completely eliminate the problem, but if you open here, you don't cause any damage here. Okay. This incubator is 5% of CO2. Here we performed our maturation and fertilization. This incubator is 5% of CO2 and 5% of O2. Here we perform embryonic culture for 7 days. The alternative is, after fertilization, to put the embryos, actually is the zygote, to put here in the time-lapse system. This is the Microscope, this specific called the MIRI, and there are six cages, in each one 14 wells, so we can put 14 embryo, and we got 24 hours, 7 days time lapse of the development. And just to show you, this is a presentation. So this is the 1 plate, okay, 1 cage, and it's taking like the figure in a circle because the camera is going around, and you can see 14 embryo, and I can give you example of this embryo. What we can see here after fertilization, we said, right? So we can see here the 2 p.m. one, and this is the other, and now we can see how it's developed. Okay, so now with the fusion, dividing to 2 cells. Dividing into 4 cells. This is already 30 hours. You can see here the time that it's running. Form fertilization. If you look around, you can see that this one are still stuck. This one, for example, is slower. We can compare between them. Morula, compaction of the embryo, blastulation, trophectoderm, inner cell mass is performed. The cell, blastocell is the cavity performed, inner cell mass, trophectoderm, and this one is finished before the other, is faster. You can see the other are slower. So by this we can learn a lot of steps going within the, this is very slow and this is very, very slow. But the problem is that what, look, this was the slower one, and you can see that it's damaged embryo.
Damaged embryo.
So it doesn't mean that if it's slow it's not good, but there is a correlation between the rate of development and the quality of the embryo.
Yeah.
So it's a very, very practical facilities for human IVF, but now we are using it for research. But it's very new, and we just arranging our thoughts, and we got another PhD student from IVF unit, and so she know everything about it, and she's going to make a PhD with this machine.
Nice.
Yeah.
Are you also making
Do about the atrazine and the aflatoxin studies, toxin, foodborne toxin. So we can check it on this embryo. But the more important, I would like to take this embryo and to check the gene expression, because probably the control of this embryo can be found by gene expression. So we have a lot of opportunity for research with bovine that we cannot make in human.
So you can make references. Can you make references?
It can be a model for human, for sure, because it's very similar.
But here you can, for example, make simulate heat stress.
Yeah.
That is good.
Heat stress or other component that can put in the medium.
I like this.
Cool, huh?
Very
Okay,
cool.
the last one that I would like to show you is the micro manipulator. You have seen it in Lisa's presentation. So there are two main functions for this one. First is to inject the sperm. Here we have a holder that we hold the oocyte, and here we have the injector that we inject this one, the needle. Go. See? That we can inject the sperm. The other procedure that we are doing is opposite, aspirating. So we're holding the embryo and aspirating one cell, two cells to.
Can this one also do?
Yeah, the same one that the same
Inject.
way that we can inject, we can aspirate.
Aspirate.
So this is older that you have negative pressure. You can hold the oocyte and the embryo, and here we can or inject or you need a lot of experience for working here. For this moment, only Alisa know to work with this machine, and we got this how you call it?